Last episode we built repositories, Parcel repository and Order repository as ports in application port out package. Adapters implements them, use case depends on interfaces. Clean separation. Now we need to fill in the use case itself. The first thing, place order needs a sender and a recipient. We have their names, email, phone. We need to find them in the system or create them if they don't exist. Let's create the first function. His name is placeOrder. PlaceOrder will return the order ID. PlaceOrder. Before I create the placeOrder command, it's a part of the CQRS. We learn about this in the future episodes. This looks like that. Okay. We paste this command here, and now let's create the sender and the recipient. So we need the party, sender party repository, find by email, sender email, or we don't find by the email, we can find by the phone. If we don't find any party, so we just create one. Okay, there is the problem. Party repository lives in the party module. Order application service lives in orders. Spring Modulith will block this import. Here has no business reaching into party internals, and even if it compile, orders knows about party as a domain object. It imports party repository, person data, that is entire party domain leaking into orders. Orders doesn't need to know what a party is. It just needs a party ID. So the question is, how does orders get a party ID without knowing anything about party? The answer is two narrow ports. A domain service holds domain logic that doesn't fit in a single aggregate root. Domain service, pure domain logic, domain objects in, domain objects out. No HTTP, no events. Lives in domain service. Application service, orchestration. Loads from repositories, calls domain services, saves. Lives in application. One test. Remove Spring from the project. Does this class still compile and make sense? In domain service? Yes. In application service, we need the infrastructure. Let's create the two narrow ports. Orders will depend on this interface, nothing else from the party. So let's create here FindParty. This lives in the root of the party package, not in application or domain. Root package is the public API of Spring Modulith module. Anything here is visible to other modules. Anything deeper is internal. Okay, so optional party ID, find by email or phone, string email and string phone. Okay, returns optional party ID, not optional party. Orders gets an ID. It never sees a party object. It doesn't know what fields party has, what methods it has, nothing, just an ID. Okay, so create another one, RegisterParty, and type party ID, register, string first name, string last name, email and phone right now. 2 interfaces, 12 lines total. This is the entire contract between orders and party. Spring Modulith will verify that orders never imports anything from party except these 2 interfaces and PartyId from the common. Now we need to implement this FindParty and RegisterParty in our Party application service. Implements FindParty and register. Okay, just implements these methods, and here we have the. Okay, we just need to inject the party repository. Party repository find by email first, or party repository find by phone, and map this for the party get party ID. Okay, here we need the party, and we need to here in the party this is the sealed abstract class, but if we create the sender and recipient is a customer, so customer it's a person, but customer is a party rule for the customer here. Okay, right now we just create the person register. So now we just paste the party ID. Okay, so UID, random UID for now. Address data. So new address data. So we just need postal code, city, street, house number, apartment. In our placeOrder command, we have the person address in person contact. So we just need person address. Have everything from here, so just put there here, and we paste this to the address data. So number, okay, it's fine. The next one is the phone, email, and we need party rule. So just paste array list and the person data. So person data, just import class like that. And now party add party rule. So party rule, and it's a customer rule code. So we just take the something random, so just customer 001 and substring plus, okay, something like that. Okay, and paste this rule here. Okay, and just save the party repository save, save return, yes, return. So our party is equal and return party. With party ID. Okay, we need update our register party interface. So just copy this one, paste here, implement. Okay, it's fine. And we just need move to the party configuration. configuration and inject party repository like that. Okay, before we create the domain service, we just need to fix something, a little bit to do in our parcel register. Here we have tracking number. We need to implement something unique. So random UID is not a tracking number. A tracking number has a structure. For example, something like that. Country code, year, sequence, something a courier can read and a human can type. So let's create the tracking number generator. It will be in our parcel domain service here. Tracking number generator. Before I write this, quick question: is this a domain service? Technically, not quite. A domain service coordinates logic between aggregate routes or holds rules that cross aggregate routes boundaries. This class doesn't coordinate anything. It just generates a value according to a business rule. It is closer to a domain utility, a value factory. The format of a tracking number is a domain rule. The class lives in domain, but I wouldn't call it a domain service in the strict sense. Worth knowing the difference. Okay, here we just make something strange. We'll change this in the future because atomic long static is multiple threads might generate tracking number at the same time. Without this, you would get duplicates under load. One line prevents a production bug. One honest caved static sequence reset on every restart. In production, you would load the last sequence from the database on startup. That is an infrastructure concern, to do for later. For now, the format is correct and the threading is safe. Sequence and new atomic long start from 1. Okay, now we create the public static tracking number, return, generate, and long sequence, so get and increment, year, local date now, and get year, and string value. We'll just use the string format. So PL, it's from Poland. Percent D percent okay, and put the year and the sequence like that, and return tracking number of value. Okay, and we just update our parcel. So tracking number generate. Okay, and we just put this here. Okay, nice. Okay, so the use case calls parcel register and gets back a parcel with a proper tracking number. It doesn't know tracking number generator exists. That is the right level of encapsulation. Tracking number generator doesn't coordinate any aggregate routes. It just generates a value. Worth knowing that is not technically a domain service. Here's the real one. When a parcel arrives at the locker, we need to find a slot that fits. Locker doesn't know about package size that lives in common. Parcel doesn't know about locker slots. Neither aggregate route can make the decision alone. Let's create LockerSlotAssignmentService. So this lives in Locker domain service. So just hide this one and create LockerSlotAssignmentService like that, and create method which will return the locker slot and find available slot. So we just need the locker and package size. Now in our locker we have the locker slots here. So we just make something like this. So locker get locker slots, and we just open the stream here, filter, so slot get locker status must be equal to locker slot status available. Now filter the slot locker size must fits to the package size with package size high and package size div. Find first or else throw new illegal state exception, no available slot for given package size. Okay, so we just fit function. Yes, it checks every possible way, even if you rotate the package. Okay. So no Spring, no repositories, locker in, package size in, locker slot out. Remove Spring from this project. This class still compiles and makes sense. This is the definition of a domain service. Logic that doesn't belong to any single aggregate root, but belongs firmly in the domain. Now we just back to our order application service, and we can remove every repository. Just save order repository right now, and we just put the party register and find party. Find party register party. Okay, and right now just put find party, find by email phone, so sender email, sender phone, or else register party register. So by here we have optional the party ID, not a party. Okay, and now we just copy party ID from here, so with a recipient. Okay, right now we need the order ID. Order ID, random UID. We can change this. We have generate. So order ID generate like that. And we need the parcel ID. Parcel ID. Parcel ID generate. Okay, we just need create a register parcel function. It's another application service. So now we have our parcel application service. So let's create the register function, but we need to use in our order application service. We just need to create the public interface. So we just name it to register parcel, and we just put the parcel ID, register parcel ID, order ID, package weight, order ID, package weight, package size. Okay, and we just implement this here, register parcel. Okay, implement the method. Okay, and now we just create the parcel register, so parcel ID, order ID, package weight, and package size. Okay, parcel repository save parcel, parcel, okay, parcel JPA entity, but the previous video I say to change this in the future, but I forgot, so I changed this right now. Parcel, and we just have the parcel, and we just use parcel entity from parcel. Okay, and we can change this to return the parcel. So okay, parcel JPA entity to domain and return. Okay, and we just update here. Okay, now it's fine. So after we save, we just put our new parcel here and return the parcel, get parcel ID. Okay, it's fine. Now we just move to our order application service, but wait a second, it's in configurations, everything okay. Now we just use our public interface, so register parcel, like that. We just register parcel dot register and put the parcel ID, order ID, CMD parcel weight, and CMD parcel size. Okay, and now we just register return parcel ID, so just put it here. So sender order now, sender order register, so order ID, parcel ID, sender, recipient, and the delivery option. Okay, and receiver order, register, and we paste the receiver order, so we just put the order ID, generate parcel ID, sender, recipient, and AMD delivery option. Okay, and we just save everything in our order repository, so sender order and receiver order. We need to return the order ID. Okay, read it top to bottom, find or register sender, find or register recipient, generate tracking number, register parcel, register orders, save everything. That is the story of placing an order. So we just need to update our order configuration right now. So we need order repository, have find party, register party, and register party. So we just delete from here, find party, register party, and register parcel. Okay, find register parcel. Okay, it make sense. Things built today. Find party and register party. Two narrow ports in party root. Orders depends on interfaces, never on party internals. Module boundary holds. Tracking number generator. Not a domain service, a value factory. Generates a value according to a domain rule. No Spring, plain Java, lives in domain. LockerSlotAssignmentService. The real domain service. Locker in, PackageSize in, LockerSlot out. Zero repositories, zero Spring. Logic that belongs to neither aggregate root alone. OrderApplicationService. Orchestration is explicit. Find, then register if missing. The decision flow is visible in the use case, not hidden in a service method. PlaceOrder works end-to-end. Two narrow ports instead of fat facade. Orders knows nothing about party except its ID. LockerSlotAssignmentService is a real domain service. Zero repos, zero Spring, two aggregate routes coordinated. Two things to take away. When you need logic from another module, expose a narrow interface. Don't reach into internals. And when logic crosses aggregate root boundaries but has no repo dependency, that is your domain service. Next episode, domain events. All this domain event comments get wired up. Receiver order assigned triggers the customer notification. Base aggregate root start doing real work. Code is on GitLab, branch. Domain service, branch of it. Open and merge request. I read them. See you next time.